I'm gonna do Alright, let's do 3 instead of 2. They don't want you to factor it, though. They want you to complete the square. Right? Because it says solve by completing the square. It doesn't just say solve. It says solve by completing the square. And let's write that down. Completing the square. Alright, so even if you can factor it, they don't want you to. Alright, they want you to learn this process. That's the whole, not they, me. I want you to learn the process of completing the square. So if you can factor it, I mean, that's lovely, that's nice. Okay, but the instructions say specifically to solve for it how? By completing the square. Alright, so if you factor it and get a solution, you're not doing what I'm asking you to do. You got it? So let's write it down. M squared minus 4m plus 3 equals 0. And you're right. If all I said was to solve for this, then you could factor this thing out, right? So negative 3 and negative 1, right, would work. So 3 and 1. I could do that in my head. But I'm trying to teach you something, though, okay? I'm not just trying to get an answer. I'm trying to teach you how to do a certain method. So it's important that you learn the method, okay, not just getting the answer. Make sense? So let's do this. This is not a perfect square, so what I'm going to do is take this, chuck it to the other side, and then fill it in with what's supposed to go there. I'm going to complete it, right, in order to make it a perfect square. So that stays the same, that stays the same. My sign is always going to be plus, right, because we take half and square it. It's always going to be positive. You don't have to put this little line here, but I do it just to remind myself that I'm going to put a number here. Okay, take this 3, move it to the other side. What's it become now? A negative 3. So really, the only thing we've done is just take this 3 and stick it on the other side. That's all we've done. Okay. Now, this is the guts of completing the square. This is the inner workings, okay, of completing the square. We got to figure out what goes here. We have to complete this whole expression right here to make it into a perfect square. So we got a little trick, right? Not really a trick. It's just the method that we use. What goes here? Or how do you know? How do you figure out what goes here? Well, you take the middle coefficient. You do what to it? Take half of it. You take half of it first. You take half of it. So watch. Off to the side, you're going 4 divided by 2, right? Which is what? 2. And then, after we take half of it, then what do we do to it? Then we square it. Everybody see that? So 4 over 2 is 2. 2 squared is 4. Now, did it matter that I made this a negative 4 right here? Didn't make any difference. Why? Because what am I going to eventually do to it? I'm going to square it. So if I square a negative 2, isn't that the same thing as positive 4? Yeah. So it doesn't really matter if you think of it as negative or positive in this situation. Got it? So that's a 4. It's a plus 4. Now if I added a 4 to the left side, what do I have to do to the right side? I got to add a 4 to the right side. Okay? Because it's got to stay even. It's got to stay equivalent to this original equation. If I just had a plus 4 here, it's not the same thing as what I had here. But now it is. This is exactly the same as this. Well, the value of it, right, is the same. All right, let's do this. We've made this now into a perfect square. So now I can put one set of parentheses in a squared, figure out what goes inside of here. Well, this times itself is m squared, so that's an m. What's my sign going to be in between here? It's going to be minus. It's always that sign right there, because this one's always going to be positive. This is the only one that could be different. Okay, so that's a minus. And then how do we figure out what goes here? 2 ways. We could either do what? Take half of this, or the square root of that, and it actually comes out to the same number, doesn't it? All right, so that's going to be a 2. All right, so now it's a perfect square, isn't it? We made it into a perfect square. What's this equal to? It's 1. Okay, let's do some work on this. Square root both sides, that goes away. Square root this side, put a plus or minus out in front. Add a 2 to both sides. Look what we get. We get m equals positive 2 plus or minus the square root of 1. But am I going to leave my answer like that? Is that simplified?
No.
No. Why not?
Because
Yeah, square root of 1 is 1, isn't it? Okay, so don't leave it the square root of 1. It's actually a 1. So technically it's what? 2 plus or minus what? 1. And we don't leave it like that. These are whole numbers, right? They're being added or subtracted. In order to simplify it, we're going to actually do that. We're going to go 2 plus 1, and then we're going to go 2 minus 1. 2 plus 1 is 3. 2 minus 1 is 1. And there's your two answers right there, 3 and 1. Was that the easiest way to do this particular problem? Probably? Right, I'm surprised. You're the one that said to factor it in the first place. Right? So what do you think? You really think it's the easiest way? Just because I asked the question like that, is that why it was? Because it was my tone? Look, watch this. I'm going to do this in a different color. And I'll try to slide it in here with all the other stuff. If all I did was say solve, and that's the only thing I asked you to do. I didn't tell you how to solve it, I just said solve it. Completing the square in this particular problem, excuse me, probably would not be the best way to solve this thing. Okay? It works. Okay? It's a good, valid way to do it. But in this particular problem, it's probably not the easiest way. Why not? Because this thing will factor. Okay? This thing actually does factor. So m and m, I got minus and minus, right? Because they have to multiply to be positive and add up to be negative. And what numbers am I going to use? 3 and 1. Because negative 3 times negative 1 is positive 3. Negative 3 minus 1 is negative 4. So that factors real nice. Watch. Set them both equal to 0. I could actually do this in my head, but I'm going to write it out. Set them both equal to 0. So what's m equal to? Equal to 3, and m is equal to 1. Same exact answer as I got right here. Look at the purple or the pink or whatever that color that is, and look at the yellow. A lot less pink, isn't there, than yellow? So don't you think this was a little easier to do it this way? Absolutely. But completing the square is the way that I ask you to do this problem. So you must do it this way in this particular problem. If all I said was solve for m, or just solve, that's all I said, I probably would factor this thing. Alright? Make sense? Okay. Remember the other worksheet we had, that 2-4A, and you had several problems where you had to factor then solve? You could actually go through those and do that by completing the square if you wanted to. Alright? But if it factors, I would factor. It just makes it a little bit easier. Make sense? Let's do another one. Let's do one of those ones where it came out to a fraction, like 7 and 8. Okay? You want to do 8? Alright, so look what we got. This is the one where we kind of hurried up a little bit yesterday. But we got some time now, so let's take our time. Okay. This is a little bit different than the other ones that we've done because of what main particular thing do you think? The 3 in front of the x squared, exactly right. This 3 right here. So we can't complete the square like normal with that 3 stuck right in front of here. Right? We only did it when it was just a 1x squared. Alright? So how do we get rid of that 3? What do we do? Divide it, that's right. We divide everything by 3. The whole entire left side, not just the 3x squared, but everything on the left-hand side we have to divide by 3. Everybody with me on that? And we also have to divide the right side by 3 as well. It just happens that 0 over 3 is 0. Alright? So it kind of doesn't look like we did, but we did. Divide the right side by 0. So let's see what we get now. That cancels out. And the whole reason we did that is so we could get x squared by itself. Not by itself, but have a coefficient of 1, I should say. Now this gets a little bit ugly, but I'm going to keep it as a fraction. Do not turn it into a decimal. Do not turn it into a mixed number. Okay? Keep it an improper fraction. You've been brainwashed too long. When you were a little kid, right, in probably 4th, 5th grade, who knows, whenever you did fractions, your teacher probably always told you to change an improper fraction to a mixed number. You probably had quizzes and tests.
You failed.
Right? Yeah. You probably had quizzes and tests where they said, here's an improper fraction, turn it into a mixed number, right? And if you were working something out and you left it as an improper fraction, your teacher may have marked it wrong because it wasn't, quote, simplified. Well, they were actually wrong, to tell you the truth. I'm calling them out right now. This is simplified. It's simplified, okay? Changing it to a mixed number does not simplify it. Simplifying it means reducing it down to its lowest terms. 16 over 3 is already reduced to its lowest terms, isn't it? Okay, so technically it is simplified. But the thing is, when you get into algebra, now look, I got nothing against mixed numbers, okay? Mixed numbers are fine. I mean, to get a final answer, write it as a mixed number, of course, that's fine. Decimals are okay. You know, turning this into a decimal would be okay, but it would come out to a repeating decimal, wouldn't it? Jacob, punch that in. 16 divided by 3. What's that? 5.3333333? Yep. So it's 5.333 repeating, right? That's not an exact answer, though, is it? So a lot of times you stick fractions into your calculator, you get a decimal. It's not an exact answer. I want to keep it 16 over 3. Have I said that enough? I've said that way too much, I think. But sometimes you just got to pound it in your heads, okay? Now, what do we do here? This is a 2, isn't it? But let's do this. What do we do with this number out here on the end? Put it to the other side. So let's do it right now. Is that all right? Save us a step from writing on all that out again. So this is a plus 2. This is a 0, by the way, isn't it? Right, 0 divided by 3. So if I stick this plus 2 over here, what do I get? Get a minus 2 because I subtract it from both sides. Now we're ready to complete the square. I'm just going to leave a blank right here. I'm not going to put that underlined thing. Is that all right? So I'm just going to leave it blank. So now, what goes in our blank? We got to complete the square. Now we're ready to complete the square. How do we know what goes inside this blank? Well, we take this middle one. Let's do this in a different color. We take the middle one, 16 over 3. We do what to it first? Right, divided by 2, or since it's a fraction like this, I'm going to multiply it by 1/2. Isn't that the same thing? It's a little easier if you do it like that. Now, after I take half of it, what do I do after that? I square it. That's right. Everybody see that? So let's work this out. This is why it's nice to write it as an improper, because look at this. 2 goes into 16, what? 8 times. So what do I have? I've got 8 over 3 squared. What's 8 over 3 squared? We square both of those things inside of there. So what's 8 squared? 64 over 3 squared, which is 9. So that's what I'm going to put right here. You see that? So that's 64 over 9. Come over here and write 64 over 9 right there. You with me so far? Now look, by taking half of this and squaring it, I made this into a perfect square. So I can write one big parentheses with a squared on the outside. What goes first here? Be x. Right, because if I was multiplied by itself, it would be x times x, which is x squared. What's my sign going to be? Plus. You always look right here. It's because of that plus right there. Now, how do I know what goes here? We've talked about this about 3 occasions today. Either half of this or the square root of this. I'm going to think of it as the square root of this. What would that be? 8/3. That's right. So that's going to be 8/3. Equals. We got to figure out what this is. Well, let's do this. Let's go off to the side. Let's use a different color. Watch. This is over 1, isn't it? So watch what we have. We got -2 over 1 plus 64 over 9. Well, we just have to write this as a with a denominator of 9, right? So it would be 18 over 9. That's right. You see it? Because 1 times 9, 2 times 9. 2 times 9 is 18. So it's negative 18 over 9. Put the whole thing over 9. Should be able to do that, right? Without a calculator. Should be able to do that, right? Yeah. Because right here, I subtracted 2 from both sides. So it was already over there. So it's -2 plus 64 over 9. So I turned 2 into 18 over 9 plus 64 over 9. What's 64 minus 18? 46. Okay. So it's 46 over what? 9. You with me? I'll tell you what. Let's keep this color coordinated here. Alright. We're getting there. That was all the completing the square stuff. The rest is the stuff that we learned earlier before we completed the square, right? We know how to get rid of the square. How do we get rid of the square? Take the square root. So that goes away. But I got to take the square root of this side. So put plus or minus. Good so far? Alright, and then How do I get rid of this plus 8/3? Subtract 8/3. So let's write it all out. So x equals negative 8/3 plus or minus, we got to break this down. Square root of 46. Well, what goes into 46? 2 does. 23 times. So can I break 23 down? No, it's prime. So really, I can't do anything with the square root of 46. So how am I going to write it? Just the square root of 46. That's all I can do with it. I can't simplify that. But I can simplify the bottom over what? Over 3, because the square root of 9 is 3. And that's it. That is the answer I read off to you, isn't it? So it took a little extra work because of the fractions. But really, what was the hard part? This part, I don't know, this part didn't bother me so much, did it? Taking half of it and squaring it? That wasn't that big of a deal. For some people, this was the worst part. It was just finding a common denominator. Yeah. But it shouldn't be the worst part. You've learned fractions long time ago, didn't you? The only problem is you might have learned it a long time ago, but guess what you started relying on? You started relying on the calculator, and you forgot how to add fractions and find common denominators, and that's a shame, all right? Because it's important. I think it's really important. Now, could you just stick this in a calculator and get this? Yeah, you could, all right? But I'm telling you, in algebra, you're going to have to start adding stuff like this. They're going to ask you to add, 3a over y minus 1 or something like that. They're going to ask you to add stuff like this together. Are you going to be able to throw this into a calculator and get an answer? No, you're not. What are you going to have to know how to do with this? You're going to have to know how to find a common denominator, aren't you? That's why I keep harping on it all the time, that it's important that you do this without using your calculator. And if all you do is hear me and get irritated by me by telling you to quit using a calculator on this stuff, but then you just turn around and use your calculator, you're not helping yourself.
It's good for checking.
All right? It's good for checking, yeah, absolutely. It's good for checking to see if you did it right, but you need to learn the process. This is not hard at all, right? 2 is the same as 18 over 9, right? Everybody could do that. That's not that big of a deal. But for some reason, this is the part right there that just kills everybody. Don't get it, but just because we're too reliant on machines. All right, enough of that. I sound like I'm 100 years old, don't I? You crazy kids and your electricity, you know. Back when I was there, we had that. Whatever. That's right. All right, we good? All right. I didn't do number 7, but you should be able to. It's pretty much the same idea. All right, so just repeat the steps, just different numbers. All right, have this in front of you, looking at it. Did you write all the steps down? I showed you every little single possible thing you need to do. All right, I left nothing out. And you just have to follow along. Take my lead, okay? All right, I'm going to give you another worksheet to practice this stuff, okay? One more time. And then we're going to get into quadratic equation. Do you remember quadratic equation from Algebra 2? Here's a sneak preview, all right? The trailer for quadratic equation. Dun, dun, dun. All right? Stop. Watch. 8x squared plus bx plus c equals 0. This is what we're going to do on Tuesday, all right? So be here. You don't want to miss it. So we're going to take this, and I'm actually going to ask you, or we're going to do it, we're going to solve for x by completing the square. I'm almost tempted to do it right now. We should, shouldn't we?
No, we shouldn't.
What? You guys should say, yeah, of course we should. Now I know how to complete the square. I got a good idea how to do it. It's fresh in my mind. We should do this right now.
Yeah, it's going to be lost.
Okay. Stop. Here we go.
You lost in an hour.
So look, doesn't this look like the one we just did? Instead of A, what was our number before from that other one? It was a 3. Instead of B, what was it? It was a 16. Instead of C, what was it? It was a 6. Okay? Really, you do the same exact steps here, except the A, the B, and the C are letters this time instead of numbers. Okay? And then you're going to work it out. This is what my college professor did. Lightning bolt. Okay? A lightning bolt strikes, and you're actually going to come out with this. To solve for x, this is the answer. It's a lightning bolt.
It's like squiggly arrow.
Crazy. It's like, how do you not know what a lightning bolt looks like? Looks like that. That's what it is right there. Okay? Once I solve for x, I do all this completing the square stuff in here. And then I'm going to get this for an answer. It kind of looks like what we just did, isn't it? What was that answer? It was negative, what was it? I don't have it in front of me. It was negative. Yeah, so it's like -8 plus or minus square root of a whatever, right, over 3, right, if you wanted to write it like that. Right? So that looks very similar to what you just got, but numbers didn't simplify because we still have A, B's, and C's in there, right? So this is what I'm going to show you. I'm going to show you how we get to this. And this is pretty cool. Why is this thing useful? Because whenever I have a quadratic, if I have anything in this form, what can you do? Anytime you see an A, where are you going to put it? You're going to put it right here and right here. Anytime you see a B, where are you going to put that number? Right here and right here. Anytime you see a C, where are you going to put that number? Stick it in right there. Do all the stuff, and you got your answer. Got it? Okay. That's a sneak preview. It's just like the movies. They tell you, especially comedies,
They tell you the whole
they tell you all the funny things, and then you watch the movie and you're like, that was the only, well, that was like the only thing funny in the whole movie. Everything else was stupid. They just showed you the funny stuff.
Is when they tell you the entire
The whole plot and everything
Yeah.
else, exactly.
That was a good movie.
Yep. Anyway, so I told you the ending. Sorry to give it away. I know you're probably disappointed, but we're gonna. This is the guts. This is the part that I really want to get into because this will really test to see if you know how to complete the square or not. Okay. Let me give you a copy of a review. It's still completing the square, and I want you to get it done, and learn how to do this stuff. Okay. That's it.